What's up? This is me, your teacher JC, and today I will be giving you a glimpse on ellipse. So first, let us define what is ellipse. Ellipse is a set of points in a plane whose distances from two fixed points is a constant. By figure, we have this figure. So this is an ellipse. So the sum of the distances of the two fixed points is a constant. Say for example that the distance of the first point or first focus, which is F1, going to a point P in the ellipse, plus the distance of the second focus going to point P is always a constant. Same manner, when there's a point, let's say point Q, connected again to your first focus, and another line connecting to your second focus. We have here that the distance from your F1 to Q plus the distance of F2 to Q is also a constant. Therefore, we can say that both of the distances are the same. So distance of the first F1P plus F2P and the distance of F1Q plus F2Q are equal. Let us define some terms in ellipse. So we have here foci. So foci is actually two fixed points. So if we have two focus, we call them as foci. So on the diagram, we have F1 and F2, whose distances from a single point on the ellipse is a constant. So there are your foci, the colored pink. Major axis, the line that contains the foci and goes through the center of the ellipse. So it passes through the center of the ellipse. That is your major axis or your x-axis for this diagram. Vertices, the 2 points of intersection of the ellipse and the major axis, V1 and V2. So these are your vertices. Minor axis, the line that is perpendicular to the major axis and goes through the center of the ellipse. So that is your minor axis. So these are the parts of the ellipse that you should know. Let's continue. Say for example you have an equation of an ellipse which center at the 0, 0 or at the origin and the major axis along the x-axis. An equation of the ellipse with that center at the origin, foci located at negative c, 0, and c, 0, and vertices at negative a, 0, and a, 0, is given by the equation x squared all over a squared plus y squared all over b squared is equal to 1. But take note, your b should be greater than 0 and it must be lesser than a, so that your b squared is equal to your a squared minus c squared, or what we call the Pythagorean relation. So this will be the diagram of an ellipse with a center at 0, 0 and a major axis along the x-axis. Equation of an ellipse with a center at 0, 0 again, but now the major axis is along the y-axis. An equation of the ellipse with center at 0, 0, foci at 0, negative c, and 0, c, and vertices at 0, negative a, and 0, a is given by the equation x squared all over b squared plus y squared all over a squared is equal to 1. Again, we have the same property. Your b should be greater than 0 and must be lesser than a. In diagram, it looks like this. So you now see the major difference of the two. If the major axis lies on the x-axis, our ellipse is in sleeping form, while the major axis is along the y-axis, the ellipse stands up. So that's the difference between the two. Let's now have an example of this. First problem. Find the vertices of the major and minor axis and the foci using the following equation of an ellipse. X squared all over 25 plus y squared all over 9 is equal to 1. Look closely with the given equation. On the x squared, we have a denominator of 25, and on y squared, we have a denominator of 9. So in here, you can now see that the major axis is on the x-axis since the denominator of the x squared is greater than the denominator of the y squared. So that will be your basis later on in finding out where the major axis lies. So whatever number, the greater the number, the denominator rather, then you can find there the major axis. So major axis is along the x-axis, as I have said, because 25 is greater than 9. Vertices, we can now find the vertices. So since we know that a squared is equal to 25, we can now extract the square root. You have there a is equal to positive, negative 5. Take note, it will always be positive and negative 5, not just 5 alone. And we have now the coordinates, that is negative 5, 0, and 5, 0. Vertices of the minor axis, so we will now be using the second one. That is your b squared is equal to 9. And b is equal to positive, negative 3. Coordinates 0, 3, and 0, negative 3. To find the foci, we now apply, okay, this one is actually not your Pythagorean theorem, but this is your triangular inequality. So as I have said earlier, your b is greater than 0, but it should be lesser than a. In here, so to find c, we will be using a squared minus b squared. And here, c squared is equal to 25 minus 9. We now have c squared is equal to 16. And extracting the square root, that is c is equal to positive, negative 4. And the coordinates, negative 4, 0, and 4, 0. So sketching now the graph of this one. The first one, that is your negative 5, 0. That is your 5, 0. That is your 0, 3. And 0, negative 3. So sketching now, that will be now your ellipse. And the foci, that is your negative 4, 0 and 4, 0. Let's have another example. Find the vertices for the major and minor axes and the foci using the following equation of an ellipse. 4x squared plus 9y squared is equal to 36. Now, this one is not in its standard form. So, therefore, we must first get the standard form of this given equation. By doing so, we must divide first both sides by 36 so that the right side will be equal to 1. Now we now have 4x squared all over 36 plus 9y squared all over 36 is equal to 1. We can still simplify the given equation. We now have x squared all over 9 plus y squared all over 4 is equal to 1. So we now get the standard form of the given equation. Let us now get the major axis. So we can find there that the denominator, the highest denominator is 9, and it is on the x square. So the major axis is along the x-axis. Vertices, we have here a squared is equal to 9. That is now a is equal to positive negative 3. And that is located at negative 3, 0 and 3, 0. Vertices of the minor axis, b squared is equal to 4, so that is positive negative 2, with the coordinates 0, 2 and 0, negative 2. Applying the same concept to find c, we have here a square minus b square. That is 9 minus 4. That is 5. So that is positive negative square root of 5. Coordinates, that is negative square root of 5, 0 and negative square root of 5, 0. Sketching now, we have here. So first is negative 3, 0, 3, 0, 0, 2, 0, negative 2. That will now be our ellipse. And for the foci, since square root of 5 is, I think that is only 2 point something, so we estimate here that it is located in there and in there. So next, find the equation of an ellipse given a vertex of 0, 12 and a focus of 0, negative 2, square root of 11, and graph the ellipse. Let us find first the vertices of the major axis. So if we notice that the given vertex is 0, 12, so the 12 there is located along the y-axis, so we can simply say that the major axis is on the y-axis. And if the vertex is along the y-axis, then our ellipse will stand up. So that is now your 0, 12, and of course, that is a mirror effect. 0, 12, and the other side is 0, negative 12. Vertices now the minor axis. To find that, we have a is equal to positive negative 12. That is a squared, so we will only square it, and that is equal to 144. For c, positive negative 2 square root of 11, so we will need to square. That is now 44. And to find for b, that is now 144 less 44, that is equal to 100, and our b will be equal to positive negative 10, with the coordinates negative 10, 0 and 10, 0. So let's now go to the definition earlier for an ellipse. So in here, we know that the major axis is on the y, so we need to place there your a. So that is x squared all over b squared plus y squared all over a squared is equal to 1. That is now x squared all over 100 plus y squared all over 144 is equal to 1. Sketching now the ellipse, we have here. So assuming that each unit is 2, that's the first 0, 12. Below is 0, negative 12. On the side is negative 10, 0 and 10, 0. So that is now your ellipse. Then the foci, that is your positive 2 square root of 11, or approximately that is 5 point something. And also on the other side. Let's continue. Let us now go to an ellipse with the center at HK with the major axis parallel to a coordinate axis. First, let us have a center at HK if the major axis is parallel to the x-axis. To get for the foci, we simply add h plus c, k, and h minus c, k. To get for the vertices, that is h plus a, k, h minus a, k, and we have the equation x minus h squared all over a squared plus y minus k squared all over b squared is equal to 1. But take note again, your b should be greater than 0 and it must be lesser than a. If the center is at HK and the major axis is parallel to the y-axis, to find for the foci, we have hk plus c and hk minus c. Vertices is hk plus a and hk minus a. The equation is a little bit different. That is x minus h square all over b square plus y minus k square all over a square is equal to 1 with the same property that should be greater than 0 and must be lesser than a. So this is now the diagram for a major axis parallel to the x-axis. And the other one is a major axis that is parallel to the y-axis. So you can now see the difference. Let's have an example here so that you may understand better. Let's find the center, vertices, and foci given the following equation of an ellipse. First is x minus 3 square all over 25 plus y minus 9 square all over 9 is equal to 1. Notice again that the denominator 25 is under x, so therefore we know the major axis is parallel to the x-axis. Center, you can now locate the center by looking at the diagram, or the equation. That is 3, 9. Major axis is along the x-axis. Vertices, a square is equal to 25. Extracting the square root, we have here positive, negative 5. That is now the coordinates. We have now 3 minus 5, 9, and 3 plus 5, 9. To simply put, that is negative 2, 9, and 8, 9. Vertices of the minor axis, b square is equal to 9. That is b square is equal to positive negative 3. That is 3, 9 minus 3, and 3, 9 plus 3. That is 3, 6, and 3, 12. For the foci, c square is equal to a square minus b square again. So that is 25 less 9, that is equal to 16, and that is positive, negative 4 with coordinates 3 minus 4, 9, and 3 plus 4, 9. And that is negative 1, 9, and 7, 9. Let's sketch. So this is the given equation earlier. Center at 3, 9. Vertices, negative 2, 9, and 8, 9. Minor axis, 3, 6, and 3, 12. With foci, negative 1, 9, and 7, 9. So let us look at the sketch. So first, that is the center, assuming that in each unit is 2 units on each of the line. So that is your 3, 9, that is the center. That is negative 2, 9. The other side is 8, 9. For the minor axis, that is 3, 6, and 3, 12. So we can now draw the ellipse with that one. And for the foci is negative 1, 9, and 7, 9. Let's have one more example. Find the center, the vertices of the major axis and minor axis, and the foci using the following equation of an ellipse. So given here is 16 square, x square rather, plus 4y square, plus 96x, minus 8y plus 84 is equal to 0. So you notice again, it is not in its standard form. So therefore, we need to find its standard form first. So what shall we do? First is, by transposing 84 to the other side, or we have the addition property of equality, adding negative 84 both sides to get negative 84 on the other side and to remove 84 on the left side. Next is we factor out. First is 16, so we place 16 outside. That is now 16 times the quantity x squared plus 6x. And on the other hand, 4 is being factored out. So that is now 4 times the quantity y squared minus 2y. Now, the next thing we will do is we will be applying the completing the square. So first is get 6 being the second term divided by 2, that is 3, and square it, that is equal to 9. For y, get negative 2 as the second term divided by 2, then that is equal to negative 1. And square negative 1 is equal to 1. So let us continue. So 16, that is now 16 times the quantity x squared plus 6x plus 9, that is now the completing the square, plus 4 times the quantity y squared minus 2y plus 1 is equal to negative 84. We copied that 1 plus 144. We get 144 by multiplying 16 to 9 because that is under the completing the square, so that is 144 plus 4, that is 4 times 1. So you can immediately see that 1 because that is on the red color. Continuing it, we have now here, since the equations now are perfect square, so that is now 16 times x plus 3 square plus 4 times y minus 1 square is equal to 64. Dividing both sides by 64 so that the right side will be equal to 1. So we have here now 16 times the quantity x plus 3 square over 64 plus 4 times y minus 1 square over 64 is equal to 1. Simplifying now, we have here x plus 3 square all over 4 times y minus 1 square all over 16 is equal to 1. So notice this equation. The larger denominator is 16 and it is on y. So we can now safely say that the major axis is parallel to the y-axis and it will stand up. Center. So center now is getting the negative of both the numerical values on the numerator. So that is negative 3, 1. Major axis, x equals negative 3. Vertices, a squared is equal to 16, that is your a, that is positive negative 4. Coordinates, we have negative 3, 1 minus 4, then negative 3, 1 plus 4, that is negative 3, negative 3, and negative 3, 5. Minor axis at y equals 1. Vertices of the minor axis, b squared is equal to 4, that is b is equal to positive negative 2. Coordinates, we have negative 3 minus 2, 1, and negative 3 plus 2, 1. And that is negative 5, 1, and negative 1, 1. Foci, again, applying that formula again, there is now c squared is equal to 16 minus 4, that is equal to 12, and square root of 12 is positive negative 2, square root of 3, or approximately that is negative 3, negative 2.464, and negative 3, 4.464. We are now ready to sketch. Let's summarize first. Center, negative 3, 1. Major axis vertices, negative 3, negative 3, and negative 3, 5. Minor axis, negative 5, 1, and negative 1, 1. Foci, negative 3, negative 2.464, and negative 3, 4.464. So let us now locate or plot the points. That is your center. That is negative 3, negative 3. That is negative 3, 5. Negative 5, 1. And negative 1, 1. So that is now our ellipse, and our foci is approximately negative 2.464 at the bottom and negative 4.464 at the top. So that is now the end of the discussion. I hope you learned something from this. Do not forget to subscribe and ring the notification bell. Thank you and have a good day.